All right, let's just jump right in. You know how we kind of think of the universe like a perfect giant machine? Like if you just knew where all the gears were, you could predict exactly what's going to happen next. Well, what if I told you that's not true? That there's a rule, like a fundamental law of physics, baked right into reality itself that says, nope, you can't. A rule that makes knowing everything completely impossible. And this really gets to the heart of it. This isn't some sci-fi concept. It's a real paradox we're going to unpack right now. It's like a cosmic trade-off that's in charge of everything, from the tiniest particles to the biggest stars. The better you know one thing, the less the universe allows you to know about another. It's wild. And this lays out that choice perfectly. Just look at it. Let's say you absolutely nail down the exact location of a particle. You pinpoint it right there. The moment you do that, its momentum, which is really just its speed and direction, becomes a total unknown, a complete blur. But okay, what if you measure its momentum perfectly instead? Well, now its location is smeared out all over the place. You can't have both. The universe literally makes you pick one.
So this strange cosmic rule actually has a name, of course. And it happens to be one of the absolute cornerstones of modern physics. It's time we put a proper title on this mind-bending idea.
Yep, it's called the Heisenberg Uncertainty Principle. And all it really says is that for certain pairs of properties, and the most famous pair is position and momentum, there's a hard limit. There's a boundary on how precisely we can know both of them at the exact same time. It's like a fundamental fuzziness that's just part of the quantum world.
Now, this might look a little intimidating, but stick with me. This is basically the code for the uncertainty principle. It's how physicists write the rule down. And you don't need to be a math whiz to get the big idea here. All it's really saying is that the fuzziness of the position times the fuzziness of the momentum, well, that number can never be zero. It has to be bigger than some tiny fundamental number. It means there's always a little bit of uncertainty left over. You just can't get rid of it. It's built in.
And here it is. This might be the single most important thing to understand. This isn't happening because our tools are clumsy or we're just not smart enough yet. It is not a human error. This quote just nails it. This uncertainty is a deep, unchangeable feature of nature itself. The universe is just wired this way. Okay, so if it's not a mistake we're making, then why? Why does it happen? Well, let's get into why this isn't some bug in the system, but a core feature of reality. And trust me, the answer is way weirder and, frankly, way cooler than you might think.
Here's the absolute key to the whole thing. Particles, like electrons, they aren't tiny little solid billiard balls zipping around. That's just not what they are. The best way we have to describe them is with something called a wave function, which you can think of as a wave of pure possibility. A particle's properties aren't set in stone until you measure them. Before that, they just exist as this spread-out wave of what they could be.
This breaks it down so well. So imagine that wave of possibility, right? If you want to know its exact location, you have to kind of squeeze that wave down into a really sharp, spiky point. But here's the catch. A spiky wave is just a messy combination of tons of different momentums. Now, what if you want to know its exact momentum? For that, you need a long, perfect, smooth wave. But a wave like that is, by definition, spread out everywhere. You have no clue where it is. And that's the bottom line. You simply cannot be spiky and smooth at the same time. That is the trade-off.
So, okay, this is a very strange, fuzzy rule about particles and waves. But, does it really matter in our everyday lives? The answer is an absolute resounding yes. This is not just some abstract theory. This fuzziness is the very foundation of the technology that basically defines our modern world.
And this is where it gets really wild. Think about this. Without this fuzzy rule, atoms wouldn't even be stable. The electrons would just spiral into the center and everything would collapse. No atoms means no chemistry, no life, no us. And the phone or computer you're watching this on, the transistors, the tiny switches that make it all work, they function because of an effect called quantum tunneling, which is a direct consequence of uncertainty. So yeah, electron microscopes, the promise of quantum computing, all of nanotechnology, it's all built on this seemingly strange, fuzzy foundation.
So let's zoom out for a second. Understanding this principle, it does more than just help us build faster computers. It actually forces us to totally change our view of the world. It makes us face one of the universe's most profound secrets.
The really big shift in thinking is this.
The uncertainty principle isn't some annoying barrier that stops us from knowing everything. It's actually the universe showing us how it really works. It's a fundamental truth about its own nature, that reality, at its very core, is all about probability and potential, not cold, hard, definite facts.
So this isn't just another rule in a physics book. You can almost think of it like a message sent to us from the cosmos itself. It's the universe whispering its deepest secret, that at its very core, it is fundamentally, beautifully, and maybe even creatively uncertain. And so, I'll just leave you with this to chew on. In that old clockwork universe, everything was basically predetermined. But in a universe where uncertainty is the law of the land, where you can never know everything all at once, what new possibilities does that open up? What does it really mean for something to be possible?